I successfully got laid off after 2 years because people think you are not important. It's very hard to find a person who has the domain knowledge as well as machine learning knowledge. If an interviewer asking you, okay, if I want to build a translation machine, what will you do? Of course, there's a lot of like very fancy methods onto it. But trust me, the more fancier method it is, I bet you have a less understanding on that.
In today's episode, we have Shaojun, who is a machine learning engineer at Meta. Welcome to the show.
Hello, everyone.
Awesome. So excited to have you on here. And you have a pretty extensive journey to get to where you are today. You spent 6 years studying for a PhD in physics before you even started learning to code. Tell us more about that academic journey and what motivated you to learn to code.
Oh, yes. So pretty much is that I've finished my undergraduate with PhD degrees. I wanted to pursuing the research career in the physics. But 6 years of the PhD actually changes a lot. So my PhD was 2013 to 2018. So during this like 5 to 6 years, things changes a lot around the world. And we know that during this period, this era, the machine learning and AI, they have a really growing so fast that I can't ignore even in the academy. I grow to the interest of the machine learning when I having a project that actually doing the interdisciplinary study between the machine learning and the physics. Actually, machine learning is quite useful for every aspect of the society. Physics start using the machine learning to help them to process the data, to help them find the signals, find the new physics. So I get fond of the concept of the machine learning idea there. I think it is much same fascinating as physics, but it's much more useful. In the physics, you usually I have a physics degree, so what kinds of job I need to do after my physics career? Yeah, usually it is very hard to find a job for the physics. But instead, for the machine learning, there's a lot of things to do. We can do something related to the social science. We can do something related to the medical science. So I decided to switch my career and then fully devoted myself in the machine learning. And then in my late PhD time, I spent like 2 years to learn how to code, to learn all the algorithms that we needed, and then successfully find something in the industry.
Yeah, that's very cool that you, even though you were so far along in your trajectory into physics, you still had the courage to change directions completely. So did you have to learn on your own, or was it part of your program where you could learn how to code, or did you learn on your own?
Yeah, I think I probably learned from my own. So actually, my learning actually comes from like two parts. One is the self-learning. So we read the literature. We have some of the Stanford open courses, like Andrew Wu's like open courses, and then to learn it by myself. And another part it is that because I'm taking the project with the machine learning to doing the researches. So I also learn the coding from my projects. So in PhD, we have plenty of time of learning into it. So my key takeaway is that we need to learn from these two both. One is from the practice, and other is the theory. So you can't lack of one of it. If you lack one of it, and you will end up with very confusion at the end of the day. It is suitable for the one who already have some idea, concepts, or concrete concepts and ideas about what is the statistics, and also good idea about mathematics. Because there's a lot of machine learning concepts, they are actually built on top of a lot of statistics concepts and the advanced statistics and advanced math concepts. And then if you don't have any concrete foundation of the math and the statistics, it's really, really hard to ramp up from there.
Yeah, it seems like if you went to university and you had some kind of STEM degree from concentration there, you have a pretty good foundation for learning. You mentioned statistics and mathematics. For someone that doesn't have that background and they want to break into machine learning, they want to apply for jobs in machine learning roles, but they have to first learn it. How deep do you need to go? Like, how much do you need to really learn here before you can actually, that's actually applicable to real life, like practical use cases?
Usually, my criteria is that you can grab one of the machine learning books and then they will explain how this machine learning works. You have to make sure that you can completely understand every word from the book. You know that you have a sufficient mathematics from it.
That's pretty deep then. Like,
Yeah, that's pretty
yeah.
deep. Fortunately, if you grab any book from machine learning, you will find they are like writing in a very good fashion. They make the algorithm as easy as possible. So there's no fixed criteria saying you must reach this level before doing the next level. But I think any undergrad statistics lesson is sufficient for making your machine learning progress. So basically, you take some statistical classes on the sophomore year or the third year of your undergrad, then you will be much more sufficient to do machine learning, to ramping up with
Yeah.
machine learning. Yeah.
Yeah, so for someone that's self-studying and is starting from scratch, maybe they have a technical background, maybe they're a software engineer, but they don't have the statistics or mathematics background. Are there any books or courses that you do recommend to kind of build your own curriculum here?
Yeah, I think my favorite course is the open courses of Stanford. The open course like a CS209, CS206,
Yeah,
whatever tool it is. And then they really have a very, very good syllabus on top of that. And then you can just follow in like every concept from them. And then every class from them will pretty much make you an expert at the end of the semester. So if you are doing the self-learning, there's no need to rush, say, okay, I have to finish this whole semester class in half a year. So you can adjust your time. Like you can take like 1 year to finish the one semester. It is okay. Just take your time, but to make sure that you understand every courses after you make it. Another one, I think the NYU also have some open classes on that. And then the third one, it is some of the machine learning algorithms. I think the best reference, it is Wikipedia. So yeah, I am always a fan of the open source, no matter open source of
yeah,
code and open source of knowledge. And then usually I learn a lot of things from the Wikipedia because Wikipedia, they have the most up-to-date progress of every machine learning algorithms. And then usually they written in a very good structures. They tell you what the overall summary looks like, and then also the reference that you need to find on top of
yeah.
that.
Yeah, like
So
you
yeah,
mentioned before, once you have to kind of know every terminology, all the words, so that you're not kind of hand waving your understanding of it. And Wikipedia is great for kind of being able to dive deeper into some of these
yeah,
either the references or links to other Wikipedia articles to really round out your knowledge. One of the reasons why you shifted from physics to machine learning is that you saw that there was a lot of practical demand. Like you could actually have a career by studying machine learning. And it's certainly like kind of a hot career right now that a lot of companies are hiring for machine learning engineering roles. Do you find that it's getting saturated? Are we far from them? Like someone were to start today, it might take them a couple of years to get to the point where they might get hired as a machine learning engineer. Will it be too late by then? Is it still very early? What are your thoughts here?
yeah. I think there's in the industry there's a mismatch of skills demand and supply for specific skill areas. So I think for general machine learning, it's quite saturated. But for the specific area, like machine learning with healthcare, machine learning in industry, particularly like a manufacturing industry, machine learning in training the large language model, etc. Like particularly in the discipline area from machine learning to the specific vertical, there's a lot of demands on that because it is easy to find a person with machine learning knowledge. It's very hard to find a person who has the domain knowledge as well as machine learning knowledge. So this is a reason why I encourage, no matter what your background it is, you should learn a little bit of machine learning because you will find a lot of opportunities inside of that. And the industry already realized that. So there's a lot of industry guys. For example, my last company, it is a healthcare company. They want to hire the machine learning engineer with health domain, at least a little bit health domain, knowing how the drugs being tested, how the drugs going to the market, what things that we are going to looking at, and also the terminology of several medical things. So it's very hard to find it. They end up hire me. I don't have any medical domain. So why
Well, now
me?
you
I
do.
am a physics
Now you
guy.
have, yeah, I like that machine learning background or skill set is not enough. Sounds like you need to pair that with some kind of domain expertise in the industry that understands and desires to apply machine learning into whatever they're offering. But how do you, I guess, any recommendation on how to build the other side, that domain expertise? I mean, it sounds like you landed on this role and you now have the experience, but like, how could someone without kind of domain to pair with machine learning build up
Yeah.
that side of the domain
Yeah,
expertise?
I think we have to separate into two kinds of new grads. The first kind of new grad is that you are not study computer science. You probably comes from different backgrounds like medical, even marketing. So in that case, the only things you need to do is to learn machine learning algorithm. And then making some projects. Either it is participating in some project, either it is a school project, or it is a project that is open source, or it's just a Kaggle competitions, and then to pick up a domain and then to dive into it outside of the job, and then showing some proven qualification, saying that you have made some successful launches. These launches including Kaggle competition, like prizes. And also, I really encourage people to doing open source projects to make sure, like for example, you can develop your own LLM agent to solve a particularly small questions in your domain expertise. Like for example, you can use LLM to classify the electronic medical records. You can use the LLM to suggest the investment, and then you can launch some of the very small websites of it. Once you have it, then you have a proven qualification saying that you already have some experience on top of it. This will give you a lot of advantage compared to other candidates when they only know the machine learning or they only know the domain knowledge.
Yeah, I like this. It's kind of building out your own portfolio. And I think when it comes to more, let's say, generalist software engineering, there's a proven kind of roadmap to building portfolios and side projects. There are ideas out there. There's a lot of infrastructure and tooling for you to launch your own side projects very cheaply and very easy to find. Does that exist with machine learning, or do you have any recommendations on what are the tools that you can use or the websites that you recommend people to begin kind of building their own portfolio of the machine learning portfolio?
Yeah, that's a very good question. So I would suggest start from Kaggle, because Kaggle is a repertoire. I usually browse Kaggle, but I not participate in any competition because I found it's quite competitive and it takes a lot of time. But a good thing is that you will find tons of data sets in Kaggle and also tons of ideas, because Kaggle actually people, they post their competition. They want to solve some of the real pain point from the business. So you can understand in different industries what kinds of problems they are focused about, what kinds of data they use. Then you can start from Kaggle. And for example, you will see a financial, for example, Two Sigma post one. Usually Two Sigma will post very hard questions there. Then you can find, okay, is there any similar questions like this? You search with Google, you ask with ChatGPT saying, okay, is there any other places I can find such domain knowledge? And then you dive into it, and then you eventually will find out a lot of gold mines there. So usually, yeah, this is what I do. I search for Kaggle and then find out, okay, what kinds of business opportunities we can find from the questions, and then combine with GPT-4 and other things to deep dive into the areas, and then eventually find what you're interested.
That's awesome. Kaggle, so KAGGLE.com for
Yeah,
anyone that wants
Kaggle.
to check it out.
Yeah.
One other challenge that you had when you were looking at this machine learning space was that there's kind of like a very blurry line between data science and machine learning, especially when it comes to the roles, especially when it comes to the job description and functions. Can you share with the audience what you perceive as the difference between the two roles, between data science and machine learning?
Yeah. I think there's really a blurring borderline for it. My definition is that data science is the one who gave the insights. Machine learning is the one who solved the problems with machine learning. My role of the data science usually is that, okay, I got a bunch of data, I train the model, and then to see how we can explain everything that happens in the data, and then to put some directions for our stakeholders, like cross functions, to see, okay, you can go into these directions to solve this problem. For example, you can increase the numbers of the recommendation here. You can decrease the numbers of a distribution of this, like of these jobs at the sectors. And then, but the machine learning engineer, it is on the other side, is that, okay, machine learning engineer has a general insight about, okay, what kinds of directions I'm going to improve my system. For example, I wanted to do a medical record classification system. I wanted to recommend these kinds of the contents to the website. And then machine learning engineer actually build the app and the infrastructures to make these machine learning algorithms happen. So one is more focused on analysis, another one is more focused on execution. Like this is the kind of role of a research scientist. You discover the opportunity from your own, and then you implement your solution of your own. But of course, being a research scientist or applied scientist, it requires the expertise of the both sides, and then usually you are overwhelming with a lot of things. So you can start from either side. If you like analytics most, you can choose data science as your career. If you like execution, you can also choose the machine learning engineer.
What's the handoff between data science, like a data scientist and a machine learning engineer?
Usually with machine learning and data scientists, they are just working very, very closely. And if you see an industry team, the team have one or two data scientists with a bunch of machine learning engineers on top of that. So they're working very, very closely together, and they are doing exactly the same thing. Data scientists, they can train the model. Machine learning engineer, they also can train the model. And usually they will switch the role at some times, like my current job. When my data scientists, they don't have any bandwidth to give us insight, then we will dig insights from our side. And then sometimes if we can't build something, we will ask data science for us to train the model. I think doing the data and machine learning is a great opportunity. You have a very flexible scopes. You are not narrowed down to say, okay, this is the only things that I need to do. You can always come up with your own projects to own and execute within your ability range. No matter what analytical or execution, you will converge to the business goal. Just make think about this. Everything is converged to the business role. And then, for example, I wanted to make some metrics movements. If you have ideas, then you execute. If you don't have ideas, then you analyze the data to find the ideas. So this is the flexibility of the machine learning and the data science role. They can switch from each other as long as you have keep a very sharp mind into it.
Yeah, it almost sounds like what is your starting point is the kind of the difference between like what the needs are, which role is more necessary, at least to start. And you actually emphasized to us the importance of understanding the business needs and aligning the technical solutions with those business needs. And this is kind of a skill set that's kind of hard to develop, especially early on, where you kind of think that you're just a hired someone that's being hired just to execute the technical details of it, but you find that it's actually really valuable to have the kind of either forethought or like the ability to zoom out and see what are the business goals that we're trying to solve. So because that's so important, you see how important that is. How do you recommend people develop this intuition to pair the technical solutions with the actual business needs?
Yeah, I think it's just to talk to the high level person, either to talk to your PM, either talk to your manager, either talk to the senior. You can schedule 101 every week or every 2 weeks with your manager to the product manager to listen to what's her top of, what is his or her top of mind. Because yeah, my experience is as I undergraduate when I enter my first job, and actually I was doing a lot of learning work, learning how to use the tech stack, because the things that we use in the industry is quite different than the things that we use in the school. And then I'm overwhelmed by the tech stack, and I never talk to anyone in the PM in the team. So I successfully got laid off after 2 years because people think you are not important. You can only just execute things and other things. So I think, okay, maybe it's the time that I switch. When I got laid off, I really, really frustrated. Then I start thinking of myself, and I doing something wrong? And then I heard some feedbacks from my previous manager, because when you leave the company, people start talking you honest. And then they say, okay, yeah, because you don't have any visibility, right? You just say, okay, I tell you to do this and you do this. Then that's great. That's great. People like you. But you don't have any visibility for the higher people. And then when they considering like layoffs or manage out someone, they just manage out someone that they don't know. So this is the real world. Okay, I am going to schedule one-on-ones with my managers, with my PMs, and that's mind blowing. Because in that cases, why you are doing this. Why you are doing this. Like they say, okay, tell you to set up this, that, set up that. And then you have a lot of questions about why you are doing this. What's the role of your work in the whole map of their work? I think managers and the product managers, they are just like, they have a big picture of their ideas. They only need the engineer to making the puzzles between it. They have a direction about how to make the puzzle. Okay, this piece is white, I want to put here. But they don't know how to actually put the white pieces in the right place, and the yellow and the green and other things in the right places. And then so that you talk to them, tell them, okay, I'm expertise in putting the white pieces. Tell me, like, why you would want to put white pieces here? They say, okay, because this is the sky, this is the water, and the water is very important to the whole landscape. So So this is the reason why we put you here. Then after that, you have a clear, no, you know how to do the white correctly. Then next time you know how to do the blue correctly. At the end of the day, you are sync with the, you are aligned with the big picture from your PM, from everyone else in there. So in that cases, you can think like them. You can think like them. You can start from the big picture and then narrow down your impact. Then you can find some projects that's critical to their whole pictures. You talk to them about your ideas, and then they will think you are very smart, and then you have a visibility from it. So yeah, I think it's a very, very long way to learn. So don't afraid of asking stupid questions, because no one will expect a new grad they will ask something very insightful. But it is very good to keep your visibility to the high level people. Try to talk to them. Try to understand. So this is my suggestion.
Yeah,
This
I
will
mean,
take like 2 to 5 years to doing that, but better start as soon as possible.
yeah, no, I really love the analogies you gave and the insight here, because I think what a lot of people, especially newer on, believe they're getting paid to do is to do what they're told. But the real value in what their companies, when they hire people, is that they want the company, they want the employees to tell them what to do, right? You're hiring someone to tell you what to do, not just to go and off and do something. And there's definitely a place and time and place for just kind of execution, but that's early on in your career. It's a very short window where that's valuable. And then you're expected to kind of do more, or face, like you said, layoffs if you all of a sudden you don't have the visibility, or you're not shown as someone that is kind of like, when people talk about being a self-starter, I think that's what they're talking about. They want someone to come and tell them, they want an employee to come and tell the manager or tell the product manager like what they think should be done instead. So I just want to talk a bit about the actual interview process. So let's say that someone is spent the time for the last couple of years studying statistics, mathematics, and went through Kaggle competitions, or have a portfolio now. Can you walk us through like what is the interview process like for a machine learning role?
Yeah, I think the machine learning role, it's pretty much like software engineering roles. So it's a little bit different than the data science and the machine learning engineer. I will talk machine learning engineer first. Usually after your resume is selected, we have a pre-phone screening with the recruiter, and then tell you about what the interview will look like, and then also your expectation of the salaries. Then the second round will be a tech screen. They will ask you, usually it's a lead code questions for the machine learning engineer, and then maybe a statistical questions or the SQL questions for data science role. And then usually for the machine learning engineer role, you won't expect any hard questions on that. Usually it's labeled easy or medium questions, because no one is expecting that the machine learning engineer is very good at really, really keen at the algorithms of coding. So yeah, but you should be prepared about the coding questions, medium or easy in the lead code. And then if you pass the home screening, you will have to go to the on-site. On-site usually have a 5 to 6 round, depending on different companies. And then it is really exhausted. It takes a whole day. And then usually it consists of the one behavioral questions, and then like 1 or 2 system design, and then 1 or 2 coding questions. And then system design also can replace by like a hiring manager interview if you are a new grad, or some of the machine learning algorithm interview to ask you deep dive into some of the machine learning algorithms. So yeah, pretty much it's very standard for every companies with a little bit short and tech focus phone screen and a very long comprehensive on-site interview.
Yeah, so this journey for you from physics all the way to machine learning was multiple years. You remember what it felt like to get your first machine learning engineering job offer, or like now all that work that you put in is finally paying off?
Yeah, I think because I got my machine learning job just 2 years ago, because before that I was data scientist. And then, yeah, it's really feel exhausted and excited because during the interview, they will ask you everything, really literally everything. Because when I enter in Meta, we have 2 rounds of the system design. One system design for distributed computing, and another is to build a translation system, something like that. And then they will dig every details from there. And then they will ask a lot of detailed questions, some questions that you don't even know the answers if you don't actually practicing it. But after that, when I start interviewing others, and I realize that actually you are not expecting to get the every right answer from the candidate. So what we only want to know is what's the way you're thinking. So don't afraid to ask questions. As I said, when you're doing the interview, don't afraid to ask silly questions. Well, when you're answering the questions, you need to make sure you have full context about it. And then after, as long as you have a full context with a proper logic, eventually you will raise an answer that is very close to the true answer.
Yeah, so now that you're a couple years into the role, you've noticed that simple machine learning methods are often outperform more complex ones. Can you say
Yes.
more about this or share an example of what you mean?
Yes. So you can see that the interviewer, they will ask a lot of questions. They will dig whatever they want to understand you. So if an interviewer asking you, okay, if I want to build a translation machine, what will you do? Of course, there's a lot of like very fancy methods onto it. But trust me, the more fancier method it is, I bet you have a less understanding on that. So it is very easy for interview to find something wrong on your statements here. And eventually they say, okay, you are not very reliable. You are not known very well in the machine learning algorithm. But on the other hand, for the simple algorithms, why it is very easy to understand for you and also for the interviewer. Because you only have 30 minutes of interviewing, there's no way to explain a very super complicated algorithm until you have full confidence about what you are doing. But the easier one, it is easy to start and easy to understand by you and then by the interviewers. And then it will also show off your deep understand knowledges about the algorithms. And then usually the interviewer asking, okay, you can start and say, oh, for example, let's start from logistic regression. Blah, blah, blah. Take 5 minutes to doing the logistic regressions. Then interviewer, they will ask you, okay, what's the details for logistic regression? And you answer that very smoothly. They're asking, is there any like better ways to do it? Then you can say, okay, let's iterate with a finer model with a multi-layer perceptions. And then eventually you go to the deep learning areas and other things. We can see that during the interview, you have a ramping up like a process. Then you can start from something that you are comfortable, going deeper and deeper and deeper, and such that you can control the reason, you can control the pace of the interviews, and then you make you like a very comfortable. And
Yeah.
then
I like that. I think that's important. That I think in interviews there's a inclination to bring on the most complex approach so that it'll demonstrate your knowledge, but inviting complexity will also invite questions and
yeah, in
doubts.
my questions.
Yeah, because an interviewer, if they don't think it's complex enough or not deep enough, they will prod for more depth and or breadth and kind of guide that way. So rather than just voluntarily lay
Yeah.
out such a big landscape, let the interviewer kind of direct you towards what direction they want to hear more about.
Yes, that's correct. That's correct.
Yeah, so
Yeah.
I'll leave you this last question then. Now that you've gone through this entire journey, what is your hot take or what's a contrarian perspective that you might have about machine learning or the career that other people might not share or might not think or might not know about?
That's a very hard question. Yeah, I think it is the business sense, the vertical domain, and then also the business sense. I think there's exist some egos from many machine learning researchers because they are very good at building systems, building wonderful machine learning projects, and then they saw machine learning actually can solve everything. But this is not the case. In the real world, things is getting much more complicated. For example, for the medical records, you can easily raise an algorithms to classify the medical records. But the most important for the medical record is that what's the risk of your model? In the medical areas, people are very like risk averse. So they wanted to make sure that everything that your output will not causing a lot of troubles. Instead, what you can do is to just spend 15 days on top of it and to build some models that it is workable. And then you start talking with other domain experts to input, to get the more guardrail about your model from there. So I think most of the machine learning, like I think I saw a lot of machine learning engineers and data science, they think the machine learning algorithms can solve everything. say, okay, I can use this one to build some insights and purely on top of it. They forgot to tell a good story about the data discoveries. To tell a good story about the data discoveries, you need to really dive into the domain knowledge. You really need to dive into the domain knowledge. For example, I'm doing the creator distribution. So I'm building the recommender systems to distribute creator contents. Okay, so this is quite machine learning programs. You match with the audience, you have piece of contents, you're doing some like embeddings into a vectors, then you match the vectors of the users, and then you find some metrics into it. But this is not the way that we are doing it. Actually, we spend almost 30% of time talk to the creators in the Facebook platforms. We talk to the users, we go through the surveys, and then to understand, okay, what kinds of the impact our algorithm can bring. Does user really like to see something that similar to they previously have seen? This is usually not the case. So it complicates your system design, and then to see, okay, we can't just rely on one algorithm. We may explore different interest discoveries. And then did the creator really respond to the distribution, your matching? Like, okay, I say, okay, I'm very proud that I match this content with potential users. But these users may not like this content and leave a bad comment. So there's a lot of complications here, and then people, and then also some of the data science they may, and the machine learning they usually ignore, because everything from them it is a number instead of story. But we need to dive into the stories, and then to make sure that your algorithms it is working as you expected.
Yeah, I like that. That it's not always about the quantitative or structured data that is useful. A lot of it's still qualitative that you mentioned. And I think with machine learning, I think what you're getting at about how it doesn't solve everything is that through machine learning models, you'll get an answer, but doesn't necessarily mean like it's the right answer without the kind of proper context and the story behind it. So that makes a lot of sense. So
Mm.
thank you so much for your time, Xiaojun. Thank you for
Yeah,
coming
thank you
on and
so
sharing
much.
your journey, your advice and experience with us.
All right, thank you so much.